Sir, can you explain this part again, that node part?
Yes. So, in single linked list, we know that the chain looks like this. So, we have to create node, and in the node you have two parts here. One is the data part, and the other field is the pointer, where we store the address of the next variable. Okay. So, we store the data here and we store the address. So, the point here is, how do we create a node first? We know that when you write a C program, you give some input and you get some output, right? So, we have seen about structures in C. We write like this: struct, you give struct name, then here you will be declaring variables int a comma b, and you will close this, right? This is general structure. What happens unless until you create an object for this structure? Okay, if you I will talk about this later. Understand this. If you create an object for this structure, right? So, how do you do that? In main, you do like this: struct, again you write the name and you write s1. Once you write s1, memory is allocated. It means in your whole RAM, we know variables are stored in RAM. For easy understanding, I will say this, right? So, in RAM, these two variables, for this tagged with this s1 variable, some 8 bytes of memory will be reserved. 8 bytes, 4 bytes for A and next 4 bytes for B. This way we will be trying to create. So, the point here is, when is the memory allocated? Only when the object is created. Only when S1 object is created, then the memory is allocated for this two variables A and B. Okay. So, if you see my linked list now, I have to create, this is just the memory block actually. This is the memory block. So, in your whole RAM of 8 GB or 16 GB, whatever you have to create some blocks like this, somewhere here, randomly at different places. I have to create blocks. Why? We know that in each node of a linked list, it has two parts. So, that is why my structure definition of linked list, struct list node, some name here. What I am giving? I am giving int data, that is to store data part, and I am creating a pointer variable int star next. I am creating a pointer variable like this. So, when you write two variables, definitely this will occupy 4 bytes, this will occupy 4 bytes. So, when you write this and create an object S1 for this, as soon as you create an object S1 for this, what will happen? In memory here, this is for data and this is for star next. Like this, a block will be created, right? So, I have to write a structure, which will, as soon as I create an object, it will reserve 8 bytes of memory in your computer, in your RAM, and where the first block of 4 bytes is to store the data and the second byte is used to store the address. Now, just now we studied about pointers. So, when I write int star next, we know that next is a pointer variable. Pointer variable. So, this next is storing address of another variable. That is the definition of pointer. Pointer variable stores address of another variable. So, this next is storing address of another variable. That another variable's data type is int. The another variable's data type is int. It means using this structure definition, okay, if I create a variable S1, okay, it will reserve 8 bytes like this, where first byte I can store any integer value because it is int, second byte I can store address of any other integer variable. It can be this int or any other int. This is what about generally it happens about structure. Now, if you come here to my linked list, if you observe my linked list, this part is data part. So, it can be achieved simply by writing int data inside structure. This is very good and simple. If I write int data, it is very clear because I have to store some numbers only, like this numbers. So, one variable inside structure can be int data. What is the second variable? Second variable is a pointer variable, right? Second variable is a pointer variable. So, I will have star next here. This next pointer variable it will store address of some other variable. What is the data type of that variable? In linked list, if you observe here, see, this is node 1, this is our first node. First node, there is some address part. It is storing address of which element? Of integer, of character, of float? No. It is storing address of another node. It is storing address of another node. Right. So, generally when you give star ptr, when you write star ptr, if you write here character in pointers, it means this ptr is going to hold address of another character variable. Same way here, if you observe, in this node I have to store address, in this node I have to store address of another node. So, what is the data type of another node? It is struct. What is the data type of another node? It is struct. That is why here we are writing same name, struct list node. What is the meaning of this statement, struct list node? See here, what is the meaning of this statement, struct list node? This next is a pointer variable. It is going to store address of another variable. That another variable is of type list node. That is what. No, if you see this block, I have another block like this, which is same as this. What is the type of this? It is of type struct list node. It is a structure. The data type of this variable is structure. Its address I have to store here. That is why we write like this. We write struct list node, the name of this structure, int data to store the integer value. Then I want to store address of something. That address belongs to another node. What is the data type of another node? The data type of another node is structure. That is why I wrote here struct list node. And that is why in linked list we call referring the same structure in the structure itself, like recursion, calling the same function in the function itself. We say it is recursion. Same way, referring to the same structure inside the same in the structure, referring this structure inside the same structure. That is why in single linked list or in linked list we use self-referential structures. Very popular interview question. Why? What is self-referential structures? Why we need self-referential structures? Self-referential structures means referring to the same structure definition inside the structure. Referring to the same structure definition inside the structure like this. Why am I referring like this? Why am I referring like this? Because I want to store in that node, this is data part which is okay, but this is the address part. I want to store here the address of the next block. Address of the next block. That is the reason we create structure like this. Okay. So, when you create this, nothing will happen. You have to write main program. In main, you have to create a variable for this. How? Write struct list node S1. Struct list node S1. Okay. So, since it is self-referential structure, we have to always create it as a pointer variable S1. Okay. We have to always create it as a pointer variable to the, we have to create pointer variable to the structure like this. Struct list node star S1. When you write this, once you create object, in C++ also we have seen, you create a class, unless until you create an object, memory will not be allocated. Same way in structure, unless until you create a structure variable, memory will not be created. Right. So, here struct list node S1 means what will happen? A memory block will be reserved in your RAM without any value here. There is no value. Now, using S1 arrow. Why am I using arrow mark? Because it is a pointer variable. To access any variable inside this structure using a pointer variable, you have to use arrow mark. In class you might have seen, when to access using object, to access the public members we are using dot. Using pointers, if you want to access the public members, you have to use arrow mark. So, S1 arrow data equal to 10, if I write, here 10 comes. Okay. If I write S1 arrow next equal to null, if I write null like this, here null is inserted. Now, since it is occupying some memory in your RAM, since it is occupying some memory in your RAM, it will have some address. It will have some address. Let that address be some 200. Let that address be some 200. Where is this S1? Where is this 200 stored? 200 is stored in a box like this. Its name is S1, it is 200 and it is pointing this. Okay. S1 is a box like this and it is pointing this way, or it's just for understanding. It is just for understanding. S1 is a box like this, but this itself is S1. This itself is S1. Okay. It is pointing to this location. It is pointing to this location. It has address 200, but it is pointing to this location. If I ask S1 hyphen data means it will give me 10. S1 of next means it will give me null. Okay. So, this way we try to create one node in the program. But now, what if I want to create multiple nodes? What if I want to create multiple nodes? Okay. So, you already have, with this code you created this, you want to create another one. So, what you can do? You can again create another object, or you, without creating another object, put that in loop, put that in loop. So, that will do that. We will see the programming part. Is it clear now about these self-referential structures? Is it clear? Did you understand this? Any doubts in this? Students? Yes, you can use class. You can use class to do the same thing. Okay. You can also use class to do the same thing. But why we cannot use class here to understand this? See, I want to create this. No, how will I create this in class? Because in class you create members. You can create. I have a class C name. Class C name. Then I will write private or public. Let me write public. After writing public, I will give int data. Now, I want to create another variable with next. So, what will I give the type of it? That is not possible with class. It is possible only with structure. Okay. This is little different compared to the structure. Right? You cannot give here class C name. It will throw error because this is not included in the C++ or class concepts. Okay, right? Self-referential structures. So, we create a node. If I write this code, nothing happens in your RAM. Okay, program has not yet started. You have to write main. In main, you have to create variable for this structure. And after creating variable, you can assign values to that. S1 dot S1 arrow mark or S1 dot data equal to 10, S1 dot next equal to null. Like this you can write it. Okay. So, we will slowly go into these concepts. Let us little increase the complexity of single linked list. Till now we have seen only how to create a memory location in your RAM. How do we create a block like this? Okay, with 8 bytes reserved, 4 bytes for this and 4 bytes for this. This is to store the data and it is to store the address of next class. Okay, let us see the next one. So, we will slowly see, do not worry, we will learn all those things separately, bits and pieces, then at the end we will try to combine it. Okay. So, operations on linked list, we can perform traversing, that is already if you have a list, you can always go through the list, right. Now, we have some operations, inserting and deleting. What is the drawback of an array? In array, we cannot insert a new element or we cannot delete an existing element. That is possible in linked list. Okay. So, inserting an element, deleting an element, we will try to see. Traversing a linked list. Okay. Assume you already have one linked list like this. So, this is called head and this variable is called tail. Sometimes they call this as tail or not, but this is always head. So you have a linked list like this. Don't get confused. Learn at least some operations of linked list. Then you will get an overall idea how to write a program for linked list. Okay, how do you implement single linked list? For now, don't get confused. Please learn it step by step. Understand things now. Then we can go for programming part. Don't directly think, sir, how will I create a linked list? What all I am teaching, it's all in in space. I do not know how to, what will happen next. Just understand the code snippets. Logic you understand, then we will write a program combining everything in a single link, in a single program. So assume there is already a list given to me. Okay, I want to traverse this list. It means I want to print every element of this list. One condition we know that in a single linked list, the last node address part will be null. The last node's address part will be null because it does not have any other node here. It does not have any other node. That's why this box is always null. Okay. So generally, how will you write? You write if condition sometimes, or while loop, for loop you use to reach the end of the array, or you are searching for a string. If you are searching for a character in a string, you will keep iterating that until you find the character. Same way, keep iterating until you find null. Okay, and stop there. See this here. See, I have a function print. I am traversing. I have a function print, void print. Now, what I am trying to do? I am trying to create a variable star head. I am trying to, always we have to create a pointer variable to a structure. To this structure, always we have to create a pointer variable. So that I have named it as head, star head. This is the input actually. This is the input. Somewhere I am passing this input. So somebody is giving me the address of this block that is available in head. That is given to me as input. You should give me starting point, right? From where should I traverse the list? I need one starting point. That starting point is head. That is given as input. Okay. Now I am trying to create another variable. I am trying to create another variable t. Let's assume temp. I am trying to create another variable temp. This should also be of type struct node. Okay. I am creating a variable temp and I am assigning head. So this temp is also pointing to this block. This temporary variable is also pointing to this block with this statement. What I am doing? Simply I am assigning the address of head. What does head contains? Head contains the starting address. It's a pointer variable. When you give the name of the pointer variable, it gives you the address. That address of this first block. The address of this first block, right? This first block, it is given into temp. So it is also pointing to temp now. Next, what is our goal? What I should do? Until this temp's next is null, keep moving forward. How to do? Current equal to head, that is temp equal to head, begin from head, check if temp is not equal to null. When temp will be null, when it comes to here, this part is null, right? Until that you go and you do current next. It means temp equal to temp next means move forward. Check this block. Is it null? No. Move forward. Check this null. Is it null? No. Move forward. Check this. Is it null? No. Move forward. It is null. Yes. Stop there. That is the for loop condition. And inside every time what I am doing, I am printing %d or cout. You can write here cout the temp of data. Temp of data. So if you see here, initially where is my temp? Initially my temp is here. So temp equal to head, it is here. Temp not equal to null, yes, it is not equal to null. It has some value 100. Maybe its address is 100, that is stored here. Its address is 200, this is stored here. This address is 300, it is stored in this box like this. Okay. So is it null? No, it is not null. Then come inside the for loop. Printf temporary data. What is temp of data? 5. It will give me 5. Again go to for loop increment decrement part. What do you have in increment decrement part? Current equal to current next or temp equal to temp next. From here temp equal to temp next means where, what is temp next? Temp next means 100. So this becomes your temp now. because temps of next contains 100. So your pointer will be pointing here now. This is erased. So temporary, this is pointing to temp now. Check, is this null? No. Print its data, that is 1. Again move, temp of temp next. So this becomes your temp. This becomes your temp. So here, is it null? No. Print its data, that is 17. Like this it will repeat. So this is the process of traversing or iterating the linked list. Okay, I will repeat it once again. Everything will be complex like this only. It will take time for you to digest about linked list. Okay, for now just try to understand the code snippets. This is what they ask in interviews. They will give a list, they will ask you to print, the traverse the list. Okay, or there are so many other operations like this. We have so many operations like this. We are going to see them. So here, what is the logic here? There is a function print. What is the input for this function? Input is the starting address. From where should I start traversing, or what is the head of a linked list? So head is here. It has some address that I am giving as parameter. Now what I have to do? I have to take a temporary variable. See, always remember, in any linked list or single linked list, don't touch the head pointer. Okay, don't play with this head pointer. It should be like that only. It should not be changing. It should be fixed at that location. If you lose head pointer, if you change or touch head pointer, you will lose the complete linked list. This is an indication that the list begins from here. So it should be always fixed. That is the reason we are trying to copy that in a temporary variable. I am trying to create a temporary variable of which type, of which data type, of this node data type. That is why I wrote here struct list node star current equal to head. Whatever memory is there in head, whatever address is there in head, that I am putting in CUR. So it will also point here. CUR also will, current variable also will point here. Now write for loop. How to write for loop? Unless you reach the null, unless the currents next is, this is data part, right? This is data part, this is next part. Okay, so if somebody asks you current of data means 5, because current is here now. Then current of next means what is there in this box. Suppose this address is 100, this address is 200, 300 and 400. Assume some random addresses. So 200 will be written here. Why 200 will be written here? Because it has to store the address of next block. That is why 200 is written. When someone prints this current of next, it will give you 200. Current of next, it will give you 200. Okay. So this way I am trying to iterate over the complete linked list. Now what I am trying to do? Current equal to head. Okay. This is my current. Current not equal to null. Is it equal to null? No. I don't have null here. I have some value in that. Next. Then go inside the for loop. Print current's data, that is 5. Print 5. From here go to increment decrement part of your for loop. What is there in increment decrement part? Here it is saying that you move current equal to current of next. Current equal to current of next. So move it forward, it is telling. Right. So next means 200. So it will point here. So this becomes your current variable now. Again check, is it null? No. Then print this data 1. Again move to next. So current will point here. Okay. So this is the code snippet logic for traversing a linked list. Any doubts here? Students, any doubts in this? Okay. Right. Why is it important to make temporary variable? Let's see this. See, head is the beginning. Head indicates that head holds the starting address of the linked list. Okay. If I don't take another variable, how will I move forward? How will I move forward? I have to move forward. I cannot move my head here. I cannot write head equal to head next. If I write like this, if I do this, my head will be pointing here. When head is pointing here, this will be broken. You will not have the address of the first variable. This first variable's address, see, it has some address 100, right? This has 200, 300 and 400. Here 200 is written. Here 300 is written. 400 is written here. Where is 100 stored? What about this 100? Who is maintaining this 100? This head variable is maintaining that 100. So if you move this head to here, if you move the head to here, whatever value was there in head, that is 100, will now become 200. So 100 is lost, and we do not know, computer or compiler does not know what was the previous address. That's why you cannot touch this head. It always has the starting address 100. That is required. Then only we will know the address, we will know the complete elements of the linked list. Okay, right? Is it clear? This is the code snippet. This is where it happens. Okay, this is the actual code. So when you write a program, you have to write this code. You have to write this code first. Then you have to write main. Inside main, you can call a function like this, print. So if till now, if we write a program, okay, assume there is only one node. So if you write a program, this is there. After that, there is main. In main, you are trying to create struct list node. This is again a simple silly one, but not the actual program. List node star head. You write like this. It means a head is created. Then you write head of data equal to 10. So in this block, it will store 10. Head of next equal to null, you write. So this will be null. And it has some address. It has some address. That is 100, that is stored here in head. So indirectly, this is our head, because head is pointing to this memory block 100. Okay, so this is like this. After this, you write the function. You write the function void, or simply you write print. You call here like this. After writing these 3 lines, you write print of star head. If you write like this, print of star head, then this function you write. This will print you, it will give you only 10. It will give you only 10, because there is only one element, and it will give you 10 as the answer. So you have to create. No, I am creating another variable, not a reference variable. It is not a reference variable, it is just another variable, right? It is same as this. You are saying I have int x equal to 10. I wrote here int y equal to x. So in memory, what will happen? This is stored here. Here it will become 10 because of this statement. Now if I do y equal to y minus 1, this becomes 9. X is not changing, right? This becomes x is not changing. Okay, that's why head is not changing. Y I can play with anything. I can do anything with y. That's why we are playing with the temporary variable here. We are trying to create a temporary variable. Using this temporary variable, we are always moving from here, here, not touching the head. Any other doubts? Yes, please. Okay, let's move forward to the next one. Again, this is calculating length of a list. Okay, we'll try to see, just try to understand logic. It will take time for you to digest linked list. You have to slowly do this. We will repeat it multiple times. Tomorrow also we will see again the same thing. I will repeat so that you understand what we are doing here. Okay, don't get confused, or don't panic by seeing these code snippets. Now I am teaching you in bits and pieces. later at the end we will combine everything and we will write as a program. By the time that Neo Collab access will be given to us, we will be doing practical exercises in the Neo Collab. Don't worry about it. They have given us time of 1 week. Within 1 week they said we will be given that username password. We will try to do that. So the next one is, given a list like this, find out the length of the list or count how many elements are there in the list. Okay, count how many elements are there in the list. Again, how you have to do? You have to create a temporary variable. You have to create a temporary variable. Unless it is null, keep doing C++. Take a counter. Take a counter, int count. Create a variable count and keep doing count plus plus. Till when I should do count plus plus? Till I get the null value. I have to keep doing count plus plus. Okay, logic is very simple. So what is the input to that function, length function? Again the head. Next step, what I have to do? Pass this head as the input to the function, like here. After this, create a temporary variable. Create a temporary variable. After creating temporary variable, check if this is null. No, then make C++, count plus plus. Again make temp equal to temp next. Move to this location. Check, is this null? No. If this is not null, again you try to no, make C++. So C becomes 2 now. Again move to next using this statement. Check if this is null. No. Then again you do 3. Again go here till it is null. So you have to increment this and then we have null here. So first to increment this, then check for this condition, then go for next. Okay, so we can see the next is null, so it will come out of the for loop. This is the logic of finding length of a linked list. We are traversing it over that. So let's see the code. As usual, there is a function length. I am giving head as the input. I am creating a temporary variable. I am creating a counter variable, count equal to 0. Same thing, temp equal to head, temp not equal to null, count plus plus, then move forward. Count plus plus, then move forward. So when you do this, current next, it will go there. So it will, you can return the count. Okay, when you have to move next, after counting it, then you move to the next. After counting it, then you have to move to the next. Right. So this will give you the length of the list. Okay. Next, yeah, the actual and the important one, the first operation, insertion. Inserting a new element in a linked list. Okay, we have seen that you can insert an element at 3 different places: at the beginning, at the end, at any given position. So we will study today about inserting element at the beginning. Inserting an element at the beginning. So if there is a list like this with 5, 4, 17, 5, 1, 17, 4 as the elements, I want to add one more element here with 3 as the value and point it to this. Then shift this head to here. Okay, how we generally add a new element into the list? First you have to create a block like this. You have to create a block like this, assign some value to that. Then this, let this be temp or new node. Let this be new node. Let this be new n new node. This new node's next you point to head. Okay, so you will write what is your statements to insert a new element at the beginning. What is general procedure? Create a node like this, assign value 3 to this. Okay, that let it be new node. So you will write new node of data equal to 3. Then you will write new node of next equal to head. When you write this, it will point to head. It will point to this block because head is pointing to this block. Now this link has been formed. After the link is formed, what you can do? But when the link is formed, it is okay. We inserted the element. But where is head? Where is head pointing to? Head is pointing to second element. Head should always point to first element. So after writing this step, simply write head equal to new node. So this will be removed and you will get a new, you will get a head here like this. Now this becomes a list like this: 3, 5, 1, 17, 4. New element is added. Okay, let's see the code and try to understand how we try to insert an element at the beginning. It includes 2 steps. So this one I have to create first. new element, new node. You see, new node I am creating with some data. Update the next pointer of the new node to point to the current head. Where is our current head? Here. Make sure that the next of the new node is pointing to head. That is done first step. Second step, this new node, wherever there is new node, you make this as the head. Okay, update head pointer to point to new node. Make the new node as head, because we know the principle or important point that the head should be always pointing to the beginning of the list. So just do these steps over. New element is inserted. Okay, how do we write the code for this? How to write code for this? Okay, don't get panic again. I say it is very simple if you understand the logic. What I am trying to do here, if the list already has some set of elements, how can I add a new element? Create this box, insert the element, point this to head, current head. Where is current head? Here. Point this to head. After that, the second step is make this new node as head. Make this new node as head like this. With these two steps we can complete. Now the question is, if the list itself does not exist, if there is no linked list at all, what you have to do? You have to just create a new node and put it null here. That's why the logic looks complex if to see here. Okay, see, I want to insert a new node. This is the existing linked list. 15, 7, 40 is the existing linked list. I want to insert a new node. To insert, what I need? I need the data and I need this head variable. If I have these two values, I can insert. That's why to me the input is head, because that's only input what we have in linked list is head always. That is the beginning point for us. So for all functions we will be giving head as the input. Okay, next I am giving the data. What is this data? This is new data which I want to add in the linked list. I am creating a temporary variable. So that let it be temp. Now temp equal to, I am allocating memory for this. How this can be done? It can also be done by creating a variable to the structure. A variable to the structure, or you can assign the value using malloc function. I hope you are aware of this malloc function, memory allocation, dynamic memory allocation technique. Okay, its type is this and its size is this. So 8 bytes here and its type is this. That way I have created a temporary variable. When you write this statement, then in your RAM this is created. Then you see, temp of data equal to data. This data I am passing 10 for example. In this place I am putting 10. Temp of next equal to null, I am putting null, right? So with these two statements, with these three statements, we are able to create a box like this somewhere in RAM, wherever there is free memory in your RAM. You don't know where is the linked list at all. You are least bothered about it. You do not know where is the linked list. You only know the linked list starting node's address, that is there in head. So somewhere in the free memory this box is created with these three statements. Now check, is the head null? Assume there is some linked list here. Assume there is some linked list like this. It has null, so it has like this. So this has 20, this has 30, this has 40, this has 50, and this is my head. Check if head is null. If head is null means if there exists no linked list. If head itself is null means there exists no linked list. So this itself is the linked list. This is the only first element in that. So in that case, what you have to do? You have to make this as head. And make sure that this is null again. That is the case if the list does not exist at all. Now what if the list exists like this? Else part. Temp next you point to head. Temps next you point to head. Okay, so this link is formed. Here it is not null anymore now. Next step, head equal to temp. So where head is here, This you remove, make this as your head. When you write this, the list becomes like this: 10, 30, 40 and 50. You get a linked list like this. So we have inserted a new element at the beginning. Okay, I will repeat this once again. Please try to understand how and why we are inserting a new element at the beginning. Okay, when you have a linked list, we have one drawback in arrays. What is the drawback in arrays? That we cannot insert a new element at the anywhere in array. You cannot insert an element at the beginning or anywhere you cannot insert. Linked list overcomes that drawback. We can insert an element wherever you want, in the middle, in the beginning, at the end. Okay, for that reason we are trying to do this insertion of at the beginning. So what input should I give? I should give which element you want to add, which element you want to add, the data, that you have to tell. And always we have only one input always for a linked list, that is head. So those two things you give. Then create a temporary variable, allocate memory for it. With this first statement in your RAM, this is created. Okay, with the second statement here 10 is inserted, I am passing 10 to the function. With the third statement, null is created like this and its name is temp. Now check if the head which is passed as an input to this function, if the head which is passed as input to this function, is it null? If it is null, means there exists no list at all. Then simply make this as head and make this null. That's it, your job is done. There is no element, you created a new element. But if this is not, if head is not null, okay, if head is not null, else case, temp equal to temp next. So there is some list like this. Okay, make this, point this to head. This is your head now. Point this next to head. So this null is removed. What was this address? Maybe 100. This 100 is stored here. Its address was 200. That 200 is stored here. This way. So you are just putting this 100 here. The address of head, you are putting it here. So this chain is formed. Next, head equal to temp. Make this as the head. Remove this from the head list. If you do that way, this becomes a new linked list, inserting an element at the beginning. Okay, so we will study next beginning, inserting at the end and inserting at any location of linked list. Okay.